Hello everyone, welcome to today's online class. We're going to explore how light behaves when it passes through lenses, specifically convex and concave lenses. Our focus will be on constructing ray diagrams and understanding how the position of the object affects the image formed. Here, we see two lenses, a convex lens on the left and a concave lens on the right. Notice how the convex lens is thicker in the middle. This allows it to converge light rays to a focal point. The concave lens is thinner in the middle. It spreads light rays outward as if they're coming from a focal point on the same side. In this class, we'll use these principles to construct ray diagrams for both lenses. Ready, class? Let's move on. 1. A parallel ray. A ray parallel to the principal axis either converges or diverges, depending on the lenses. 2. A focal ray. A ray true or appearing to come from the focal point behaves oppositely. 3. Central ray. A ray that passes through the center of the lens that travels straight without bending. Look at the diagrams here. The lines show how the rays bend as they pass through each lens. Keep these behaviors in mind as we move forward. Now let's start with the first scenario, an object placed beyond 2F. For the convex lens, look at the rays converging to form an image between F and 2F. The image is real because the rays actually meet, as you can see here. And the image is inverted and smaller than the object. For the concave lens, the rays diverge, but when extended backward, they form a virtual, upright, and smaller image on the same side as the object. Comparing the two diagrams, can you see how the convex lens bends the rays inward while the concave lens bends them outward? Next, we place the object directly at 2F. With the convex lens, the rays converge at 2F on the other side. The image is real and inverted and the same size as the object. With the concave lens, notice how the image remains virtual, upright, and slightly smaller than before, yet still on the same side. As you can see in the diagrams, the behavior of the rays doesn't change. It's the object's position that dictates where the image forms. Now, let's move the object between 2F and F. For the convex lens, the rays converge to form an image beyond 2F. This image is real, inverted, and larger than the object. For the concave lens, the image remains virtual, upright, and smaller, but appears closer to the lens compared to the previous scenario. Notice how the convex lens magnifies the image while the concave lens consistently reduces its size. Here's an interesting case. What if the object is placed directly at F? As you can see here, for the convex lens, the rays emerge parallel, meaning they never converge to form a real image. Instead, the image forms at infinity. So, basically, we say that there is no image. For the concave lens, however, the image continues to be virtual, upright, and smaller, appearing closer to the lens than ever before. Look closely at the rays in the diagrams. This is a unique case where the convex lens doesn't produce a clear image. Finally, let's place the object between F and the lens. For the convex lens, the rays diverge after passing through the lens. When extending backwards, they form a virtual, upright, and magnified image on the same side as the object. For the concave lens class, as always, the image is virtual, upright, and smaller, very close to the lens this time. This shows the biggest difference in image characteristics between the two lenses. The convex lens magnifies, while the concave lens minimizes. Now, class, let's summarize everything we've learned so far. A convex lens can produce real or virtual images which can be magnified, reduced, or the same size depending on the object's position. A concave lens always produces virtual, upright, and smaller images. Now, take a moment to review the summary table that I'm presenting to the class, which compares these scenarios side by side. That's it for today's lessons on ray diagrams, class. Remember, lenses are everywhere in the real world. From glasses to cameras to telescopes, understanding how they work will help you appreciate these technologies. If you have any questions, feel free to ask or private message me later. Goodbye, everyone, and have an amazing day.